Hello there everybody, this is Ed with High Point coming at you today with a video on Cheshire Collimating Eyepieces and how to use them with your Newtonian or Dobsonian telescope. Alright, let's get into it. Now this video is going to be broken up into timestamps, so if there is a specific section that you're interested in, check the timestamps down below to find and jump to that specific section. Additionally, we have released a written guide to go along with this video, so if that's something you're interested in, check the description box down below for a link to that. Finally, if you haven't picked one of these guys up already and you're interested in doing so, check the description box down below for a link to that. So, what is a Cheshire Collimating Eyepiece? Well, briefly, it's a tool in a number of tool-assisted methods that allows you to collimate your scope a little bit more easily or a little bit more conveniently than using a tool-less method, like perhaps a star test. A Cheshire, in particular, allows you to dial in this collimation during the daytime so that you can, run through this process and prepare for the clear skies instead of with something like a tool-less method, like a star test, waiting for them arrive and then consequently using some of the observing time that you have to dial everything in. The way that they do this is by giving you a set of visual reference points so that once you insert this into the focuser of your telescope, you can use those reference points to align the different optical elements. Now the way that a Cheshire Collimating Eyepiece does this is with a little bit of clever design. First, there's going to be a small aperture or hole on the top of the tool to keep your head nice and centered while you're running through this process. Next, there's going to be a reflective surface to give you a nice bright circle to use as a reference point. A lot of designs are similar to this Apertura Cheshire Collimating Eyepiece, where you have a 45-degree surface that's behind a cutout like this, which catches stray light or outside light and, gives you that nice bright circle. I'm quite partial to the Apertura Cheshire Collimating Eyepiece because they've gone ahead and polished this to really help grab some of that light and give you a nice bright point. Next is going to be a set of crosshairs up at the front that you're going to use to mark off a center point and align the different optical components to. Now manufacturers do have to strike a balance with this so that you don't have something so thick that it's obstructing your view, but not so thin that you can't see it or that it's easily damaged if you were to, say, knock this on something or accidentally hit it in some way. The Apertura Cheshire achieves that balance nicely by giving you a set of stainless steel bright wires up front to mark out that crosshair. Lastly, what you'll notice is that on a lot of these Cheshires, the crosshairs are set at the end of a long tube like this. The reason for this is that the further away these crosshairs are from where you're looking into the tool itself, the less of a misalignment you can get on those crosshairs and consequently that center point. That will usually come with the trade-off that this is now going to sit a little bit outside of your focuser and make it perhaps a little bit uncomfortable to use, or the design will be such that it gives up a little bit of that precision to allow this to sit further into the focuser. The Apertura again hits a great balance here by, instead of shouldering this long tube like you'll see on a lot of other designs like this, it's 1.25 inches all the way to this section here, so this can be inserted quite far into your focuser while still maintaining that longer tube and that increased precision. Before we dive down into the tabletop view for the setup and collimating instructions, I do just want to take a quick second to say, if you guys aren't subscribed already, we would appreciate it if you'd consider doing so for more how-tos and astronomy product-based content. If you find today's video helpful or informative, we'd appreciate if you'd also consider giving it a like. Lastly, if you have any comments or thoughts on the topic of today's video, please leave them down in the comments section down below. As always, we'd love to hear from you. The first step is to prepare the area that we're going to be running through the collimation process in. Now, since we're going to be lining up all of these elements by eye, we want to make sure that, number one, it's nice and bright so that we have something bright to point the front of this telescope at, and additionally angle this 45-degree polished surface on the Cheshire Collimating Eyepiece towards. so that, we have some nice bright points of reference to align everything and make the process easier on ourselves. Now, if you have a nice flat surface like a wall or a ceiling that you can angle this at, that would be best, as that helps, evenly illuminate and allow you to distinguish, which part is which, and easily distinguish, the crosshairs and center spot of the primary mirror, which may otherwise get a little bit lost if you have a more detailed or interesting backdrop that you have this pointed at. Now, while we are going for brightly lit, I do want to make it a point that you don't want to point this at something you wouldn't otherwise point your telescope at, namely the sun, but also just anything that's exceedingly bright that might make the experience uncomfortable or perhaps dangerous. The next thing to consider is where you're going to be setting the telescope up at. I have it on this nice large work surface here, and if you are going to take your telescope out of the mount, this is something that I would recommend, so that there's no concern whatsoever that in the course of manipulating this you're going to either knock it or drop it onto the floor. But you can just as easily leave it in the mount if you're able to bring that to a location that is nice and brightly lit to run through the procedure. Lastly, you want to make sure that you need any tools to run through the alignment process. If you need a screwdriver or a hex key for either your secondary mirror or some special tool for your primary mirror, that you have that handy before getting started. There's nothing worse than getting partway through the process and then finding out that you have to leave the telescope on the table here to go over and grab something. And then when you come back, you of course risk, bumping the setup or jostling things, which is never good. So just make sure that you're prepared before running through this. Anything that you're gonna need, make sure it's, nearby, easily reachable. Okay, so I've got my Apertura Cheshire Collimating Eyepiece. I've got a nice well-lit environment, a large work surface. I don't need any tools to collimate this particular scope because the primary adjustments on the Celestron StarSense Explorer DX130 are all manual, and I've installed the Apertura secondary mirror upgrade knobs onto this particular unit, so I don't need any tools or anything like that, so I'm all set to go, right? Well, hold on just one sec. So for the first time looking through the focuser, and then when we add the Cheshire Collimating Eyepiece on top of that, you're going to be seeing a number of components through here that may not intuitively, correspond to these components that we're going to be adjusting, or maybe you're not sure what they all are. So before we start here, I do want to just make sure that we're all caught up on what each component is, so that when we run through the instructions and I'm talking about what we're trying to align where, we all, you're able to focus on the process itself rather than trying to figure out what exactly I'm talking about. Let's start without anything in our focuser and with the focuser racked in as far as possible. That means collapsed, as far into the telescope as it can be. Now from here, I want you to go ahead and look straight through the focuser and, take in what you're seeing behind it. Now what you're going to see is you're going to see a view of what's in front of the telescope, and you're also going to see your eye staring back at you. What I want you to do is stop focusing on all of that for a second and try and take in what you're seeing all that through, which is going to bring us to the first component, which is the secondary mirror. The secondary mirror is that smaller angled mirror that's up front here. It's behind this assembly and is adjusted with these screws right here on this model. And what it's looking at is our primary mirror back here. That brings us to our next main component, which is the primary mirror. That's what's looking through the front of the telescope, and so you're going to be able to see whatever this is pointed at currently, and if you were to say, wave your hand in front of the telescope, you'd be able to see that as well. So that brings us to the reflection of your eye. You're gonna see your eye in a circle with some crosshairs, on either side of it. In this case, those are these spider veins that are attached to the secondary mirror. The primary mirror's view is partly obstructed by the secondary, and so what you're seeing is the light that's being reflected from the outside, in this case, off of our eye, reflected onto the primary mirror, and then we can see that through the reflection of the primary mirror on the secondary. That all may sound a little bit complex, but all you really need to understand is that everything that we're looking at is in the reflection of the secondary mirror. Now, that's taking a look at our primary mirror, which can see through the front of the telescope, and it can also see what's reflected out here as well. All that's really going to change when we put this Cheshire Collimating Eyepiece into the focuser here is we're going to be looking through a set of crosshairs, so everything's going to have a big blurry set of superimposed crosshairs on top of it, and then we're going to be replacing that reflection of our eye with a reflection of the collimating eyepiece that we're putting in here. That's where this angled 45-degree polished surface comes into play, so that we have a clear, bright point of reference to start lining everything up against. So again, you want to make sure that this is pointed towards some illuminated source to make sure that we have a nice, bright reference point to align everything to. Now first you're going to want to start by making sure that your focuser is again racked all the way in, so fully collapsed. There we go. Now we're going to go ahead and loosen any of the compression fitting or just eyepiece retaining screws here. Grab our Cheshire Collimating Eyepiece and insert it all the way in to the eyepiece holder. Now there's a couple of things that we want to pay attention to before we lock this in place. Number one is, again, we want to make sure that the 45-degree illuminated surface here is pointed towards a nice either light source or illuminated surface on the outside, so that we have a nice clear view in the reflection of our primary mirror of our Cheshire Collimating Eyepiece here. The second thing is that if you were to look through the Cheshire Collimating Eyepiece at this point, you're going to see the superimposed crosshairs of this eyepiece. Now, if there's a particular orientation that makes more sense to you, in other words, if you want this to be in an X to contrast against these spider veins up front here, or if you want them to be more in line with those, you can rotate this until they line up in whatever orientation makes the most sense for you. I'm going to go ahead and look through and just make mine up and down. And now that I can see the collimating eyepiece nice and clearly in here, I'm going to go ahead and lock this down. With that in place, we're going to start at the front of our telescope and work our way back. So I'm going to start with the secondary mirror adjustment here. Again, I have these upgrade knobs installed. You might have maybe some hex head set screws or Phillips head screws depending on your telescope, but typically there will be a set of 3 adjustment points here that you'll need to tighten or loosen to set the tilt of the secondary mirror. Now what we're looking to do when we're adjusting the secondary mirror is ensure that we have a centered full view, or as full as possible, of the primary mirror. Now this telescope and a lot of telescope designs will have a feature that makes this easy to do. You might have noticed it when looking through the focuser without the Cheshire Collimating Eyepiece installed, and that's a little circle or dot at the back of the telescope on the primary mirror to mark the center point. This is what we refer to as the center spot, and it's going to make this process nice and easy for us. So again, we're going to be looking to get the view of the primary mirror as centered as possible. And in the event that you have a center spot, all we need to do here is pay attention to the big superimposed, so that big blurry set of crosshairs that we're looking through to see everything else, and the center spot. So keeping an eye on that center spot and the center point as marked out by those big superimposed crosshairs, you're going to start adjusting these screws or adjustment points. Now, since you can't see through the Cheshire Collimating Eyepiece while I do this, we're going to be rolling a graphic up on screen to help demonstrate what I'm doing here. Either tightening or loosening these adjustment points. and paying attention to how the center spot and the view of the primary mirror is moving while I adjust these. Now, once I've gotten to a point where the center spot is right behind that superimposed, where those intersect, that center point is marked out by the crosshairs that we're looking through here, I'm going to be good to go. Now, if you've never run through this process before, there are a couple of things that you want to keep in mind. What you'll find sometimes is that loosening one of these screws leads to the most improvement. However, you get to a point where I can feel it right here, you won't see any noticeable improvement, or you'll just see large jumps in the center spot and the view of the primary mirror, but it doesn't feel like this is actually contacting anything at all. In that case, what you can try to do is tighten down some of these other collimation knobs to try and tilt everything back so that this is making contact again. So I can feel here, yeah, that's making contact, so I can tighten this down a little bit more. That's making contact again, so I can back it off just a bit to continue that movement. Now I can feel it's loose again. I'm gonna go ahead and try and tighten this down to get it to contact again. But ultimately, it's not making contact at this point. What you'll want to do at that point is try and find a combination of tightening and loosening these other screws that allows you to continue that positive movement towards the center. Now, what we recommend is that you try using only 2 of the 3 adjustment points to try and get everything centered. Typically, you can find 2 that make the broadest improvement, stick with those, and get everything nice and centered. However, in some cases, you may find that you do ultimately need to adjust all 3 adjustment points to really get it dialed in and centered. Now, that's okay. Again, part of the advantage of using a tool-assisted method like this is that we're able to do it during the daytime when we have, much more time to get everything dialed in. So just relax. There's no rush. Just make sure that you adjust all of these until everything's as centered as it possibly can be, and so that you have at least a little bit of tension on each of these screws. You don't want to get to the point where anything's so loose that you're not seeing any improvement and it's able to spin without feeling like it's contacting everything. You do want to make sure that each point has at least a little bit of tension on that secondary assembly. Once we've got that view of the primary mirror is centered in the secondary as much as possible, and its center spot correspondingly lined up with those superimposed crosshairs as much as possible, it's time to move on to the rest of the components. What you'll see is that even though we centered the primary mirror, the rest of the components are somewhere off to the center of that superimposed, crosshair center point. What we're going to be doing now is adjusting the primary mirror to bring the rest of those components in as centered as we possibly can get them. Accordingly, I've flipped around our Celestron StarSense Explorer DX130 here so that we can adjust the primary mirror adjustment points to try and center those components. Now, what this looks like is going to be dependent on what telescope you have. Again, you can see on this DX130 here, we have these tall thumb screws and then the shorter, thicker thumb screws. If you were, for example, looking at an 88, however, you'd see a set of 3 white knobs and a set of 3 black knobs, whereas the white knobs are going to be the locking knobs and the black knobs are going to be the adjustment knobs. You'll have to take a look at your manual to see what the adjustment system for your particular scope is. But in this case, the taller knobs are the lock knobs, and so I'm going to go ahead and start undoing these so we can adjust the tilt of the primary mirror. Now, the purpose of these locking knobs is that once we've dialed in the tilt of the primary mirror and get it so that it's directing all of the light to as center a point as possible on the secondary, we can then use these to lock it in place. However, you do want to make sure that these are nice and loose so that they're not interfering with any of the range of motion that we're trying to get out of the primary mirror here. If you only unlock these a little bit, you could run into a situation where you go to loosen one of these and it bumps up against the lock knob, stopping you from getting any further adjustment back in one direction or the other. Now that I've got these all nice and loose, I'm going to go and take a look back through my Cheshire Collimating Eyepiece. What I'm going to be paying attention at this point in time is those superimposed crosshairs and then the reflection of the Cheshire Collimating Eyepiece in our primary mirror. Now in the reflection of our Cheshire Collimating Eyepiece, we're going to see a big dot in the center, which is actually what we're looking through, and then we're going to see a reflection of the crosshairs, you know, those big superimposed ones that we're looking through, in the reflection. What we're going to be doing at this stage is moving the reflection of those crosshairs, so the smaller, you know, illuminated circle with the crosshairs, and we're going to be lining that up behind the larger, big, superimposed crosshairs that we're looking at everything through. And so similar to our secondary mirror adjustment, we're going to just be tightening and loosening these adjustment points until we get that all centered. This is similar to the secondary mirror adjustments in that you could conceivably loosen these to the point where they're no longer touching the primary mirror at the back here. Again, if that happens, you can try and adjust a number of these points to try and tilt the mirror back until it's making contact again. Or you may need to switch to using another set of these knobs to try and walk it back in the direction that you're trying to go. Now what you'll find here is that typically you'll only, again, need to adjust 2 of the 3 adjustment points to get everything dialed in. You know, use 2 of these, the 2 of these that make the most positive impact on getting everything centered, and relegating the third one as a pivot point. However, unlike with the secondary mirror, where you could simultaneously look through the Cheshire Collimating Eyepiece and adjust those secondary adjustment points simultaneously, regardless of which telescope design you have, what you'll find, particularly in Dobsonian designs, is that these primary adjustment points are going to be too far back for you to adjust while looking through the Cheshire Eyepiece. So does that mean that you're going to be stuck adjusting one of these, primary cell adjustment points, running over, taking a look through your Cheshire Collimating Eyepiece and seeing whether that made an improvement or detriment to the centering of everything, and then running back and redoing everything until it's all centered? Not quite. I'm going to show you a little trick here that you can use to figure out which of these 3 adjustment points is going to give you the most improvement towards the centering of all of the components we're looking at through the Cheshire Collimating Eyepiece here. What you're going to want to start by doing is taking a look through your Cheshire Eyepiece, noting where the center point of those superimposed crosshairs are, and then drawing a line to the center of the reflection of the collimating eyepiece that we're trying to get lined up behind those superimposed crosshairs. Now once you've drawn that eyepiece, that's the direction that we need to move most in order to bring everything down to that center point. What you then want to imagine is that line going to the outside of the telescope. Once you've drawn that imaginary line to the outside of the telescope, while still looking down our Cheshire Collimating Eyepiece, now put your hand in front of the telescope. What you're going to want to now do is move your hand along the outside of the telescope until it's lined up with that imaginary line. So say, for instance, I draw my imaginary line, I'm looking through my collimating eyepiece, and I can see that it lines up when my hand is right here on the outside of the telescope. What I'm going to do from this point is trace that to the back of the telescope here. So that will just say, for this example, line up with this spot right here, and then continue that on to see which of the 3 adjustment points is most in line with that spot that I traced. In this case, it's this screw here. So I would then loosen this screw, go and look through my Cheshire Eyepiece again, see if that made an improvement. If it didn't, I'd come back and I'd tighten this screw. Now you can repeat this process, so say I've got this adjusted to get it as centered as possible, but I still need some additional movement, again, because you'll typically need at least 2 of these 3 points to get everything centered. So what you can do again is draw another imaginary line between our superimposed crosshairs, the reflection of our Cheshire eyepiece, and the outside of the telescope. Line up your fingers with where that line meets the outside, trace it all the way back, and then whichever screw is most in line with that point is again the one that you're going to want to adjust. So in this case, if it was over here, I traced this back, and my point ended up back here, this is the screw that I'd want to start adjusting. Now, again, you're gonna keep working through these adjustment points until you've got the reflection of the Cheshire Collimating Eyepiece and its crosshairs as centered as possible behind the superimposed crosshairs that we're looking through, when we're looking through the Cheshire Collimating Eyepiece down at the rest of the components in the optical train here. After you've lined up the reflection of the Cheshire Collimating Eyepiece, its crosshairs behind the large superimposed crosshairs that we're looking through at all the optical components, it still doesn't look like everything's quite centered. You might notice a little bit of a shadow or an enlarged, darkened portion on one side of the reflection of the Cheshire Collimating Eyepiece, that's larger than on the other side. And consequently, everything looks like it's just shifted a little bit over. This arises due to the fact that a lot of Newtonian and Dobsonian style telescopes have what's called an offset secondary mirror. With these designs, the secondary mirror is just that. It's offset just a bit from center. Now, this offset doesn't affect the performance of the scope. It's designed to have that offset in there. However, it is going to be noticeable when you're looking just through this Cheshire Collimating Eyepiece. And so, you're either going to be able to get the reflection of the Cheshire Collimating Eyepiece centered within that darkened circle so that it's no longer elongated or bulging out on one side, or you're going to be able to get the reflection with the crosshairs centered behind the superimposed crosshairs that we're looking through. Of the two, the one that you want to focus on is, again, getting the crosshairs and the reflection of the Cheshire Collimating Eyepiece lined up behind the superimposed crosshairs of the Cheshire Collimating Eyepiece that you're looking through. That's the condition in which you're going to get the best views that you possibly can, at least when using the Cheshire Collimating Eyepiece tool. Lining the optical elements up that way is the way that this scope was designed to be aligned and is what's going to give you, those best possible views. Now, once you're done getting the reflection of the Cheshire Collimating Eyepiece centered and you're done using the primary mirror cell adjustment points here, what we need to go ahead and do is lock this back in place. Now, that may seem simple enough, just tighten this down until you feel it tension, move to the next one until they're all locked into place, maybe then go back and snug them up. However, what we want to do is more of a controlled tightening so that we don't torque down one section of the mirror too tightly before we get the rest of these tightened down. We want to apply more of an even pressure. Accordingly, what you want to do is just tighten this down a little bit, tighten down another one a little bit, tighten down another one a little bit, and just rotate through until you feel them all touch. Once you feel them all touch, go ahead and just add a little bit of tension, a little bit of tension, a little bit of tension, and then snug, snug, and snug. And we're all set. At this point, your scope's going to be collimated, and so you can go ahead and remove the Cheshire Collimating Eyepiece from the focuser and get this back and ready for action. Okay guys, you should now have your scope collimated and ready for some superb views. However, if you did run into any issues, snags, or just have any questions about the process in general, please don't hesitate to give us an email, a call, or reach out to us in the comment section down below. Thanks so much for watching today's video, guys. I hope you found it helpful, and as always, until next time, clear skies.